Hey everyone, it is June 21st, 2019. Happy summer solstice. It is 63 degrees out. It is 08 in the morning, well 08. And it is Geo-Rant time number 106. Okay, but anyway, I'm going to talk about cycles as they pertain to geology. This concept that we as humans have and this need to make everything nice, orderly, and easily predictable. Okay? And when it comes to nature, and especially geology, there are so many factors that go into an event or a long period of time, which means more stuff can happen, that this concept of cycles is irrelevant. All right, and I wish people would stop using it. I'm going to talk about supercontinent cycles. I am going to talk about polar magnetic reversals and Yellowstone. And maybe not in that order, but I will start with supercontinents. First of all, something I need to say about supercontinents. You don't need all the land masses joined together on the planet to have a supercontinent. All right? A supercontinent is just about 40% of all cratonic land masses in one continent. We do not have that situation on Earth right now, although Eurasia is close at about 36 or 37%, something like that. All right? But Pangaea. All right, talk about Pangaea because that's what everyone knows, even though there's been more than one. That's kind of like a mega supercontinent. But even during Pangaea, all land masses were not together. Crimea and I believe Indonesia were still separate. So we've never had a situation on Earth where all the land masses have been joined together, all continental fragments. Has never happened. It's been close, but it's never happened. And a lot of times in these supercontinent cycles, like Nunia and Colombia, you'll get like 50% or 60% of cratons will be getting together, but not 90. Okay. So that doesn't happen. And you'll hear people say, well, about every 500 million years, we go through a supercontinent cycle. All the continents come together and then they rift apart, then they come together. That's crap. Okay. And it's not the same thing as a Wilson cycle, by the way. A Wilson cycle is just the opening and subsequent closure of an ocean basin. All right, it doesn't have to be on a global scale. It can be local, like with the Huronian rifted and was subsequently closed. That ocean basin was closed during the Pinocean orogeny. So that's a Wilson cycle. It's not the same thing. And we've actually known about Wilson cycles before plate tectonics, which is kind of funny. Anyway, so back on track. This notion that supercontinents do break up and do their thing and come back together does happen. It is a cycle per se. But when somebody attaches a numerical value to it, it's garbage. It's not about 500 million years because it's about 500 million years plus or minus 200. That's a 40% margin of error. Okay, so it's not a cycle. It's ridiculous. I'm tired of it. I don't want to hear it anymore. The next one, we are going to actually we'll deal with the Earth's magnetic reversals here. Okay. I've heard people say stupid stuff like, oh, the Earth's magnetic poles flip every 100,000 years or so. And yes, they do. They do flip. We know that. We have the Earth and we have a dipole type situation. The textbook thing you've all seen, here's Earth and the little bar magnet in the middle and the little magnetic lines come in. It's oversimplification because we have things like the South Magnetic Anomaly. So we have a close to but not perfect dipole situation. I believe the Sun and like Jupiter do. Okay, so, but we're close. All right, and this has been in operation for about 3 billion years that we've had that dipole. There's other ways you can have magnetic fields, like not dipolar. But anyway, I regress. So we know these things flip. Okay, comes to a point north, point south, north, south. But the thing is, in a geologic time span, that happens instantaneously. Okay, and we're talking about geologic time. In reality, I don't know how long it takes. Well, we know it's more than 100 million or 100 years. We may be in one right now, or we may be in a lull. We don't know. But, a full-on reversal may take 500 years. It may take 5,000 years. I don't know, and I don't know if we're in one, although we do think that it's a very good possibility that we are in the beginning stages of one. But anyway, that aside, I hear people say, well, we're overdue for a magnetic reversal. It's been 700,000 years. Actually, the poles have reversed. They just haven't permanently reversed in that time. In that 700,000 years, there's been a couple minor hiccups where it's flipped south and then flipped right back to north. So that happens too. And you start looking at reversals through the Phanerozoic, even though now we're starting to get good ones on the Precambrian too, during the Paleozoic and the during the, not Paleozoic, my bad, during the in the Precambrian, we're starting to get good magnetic data for the Neoproterozoic and the Mesoproterozoic. There, okay, that's, but this notion that it's every 100,000 years, plus or minus 600,000, I mean, come on. Seriously, it's a non-thing. The only pattern is they flip. Okay, there's no overdue. There's nothing like that. All right, the poles will reverse when they reverse. All right, there's so many factors, and we have a decent understanding, but obviously we don't have a good one, because that's the kind of thing that we should be able to predict if we had enough information. We're missing something. So anyway, at least that's my opinion of the situation, because that's physics, and physics is a lot more predictable. Simple laws and individual things like orbits and stuff like that, and that kind of stuff is more simple. There's not this vast complexity that you see with natural systems. I hope that made sense. If someone's going to say something about that, but in my head it sounded better, I think. All right, let's get to the third one, since we're at 6 minutes and 35 seconds. The third one would be Yellowstone. Yeah, okay. Yellowstone is a super caldera. It's a hot spot of magma. As the plates move about the globe, North America, this hot spot in the mantle relative to North America doesn't move. You can actually look on the shaded relief map of the United States and see where it's trailed. Okay. We have others of these in the geologic past up to the Precambrian. We had the St. Francis Mountains in Missouri. That was one as well. So these things have been around for a while. Okay. And I hear people say, because I think it's been about 600,000 years since the last Yellowstone eruption. People sit there and say stupid shit like, oh, we're overdue for a Yellowstone eruption. No, we're not. Yellowstone will erupt when Yellowstone erupts. Okay? That's one of those other things. I mean, and Yellowstone, the thing with these super calderas is they could erupt every million years or more, or every tens of thousands of years. The amount of magma released varies greatly, immensely, from not much larger than a normal, like Mount St. Helens type eruption, to extinction level events. So there's no cycle there. Okay, Yellowstone is not overdue for anything. Okay, it's been 600,000 years. So what? I think the longest span was longer than that. It doesn't matter. There is no cycle, and let alone one you can attach a number to. All right. I wish people would just stop saying that. Okay, but anyway, so we know there's no such thing as a Yellowstone eruption cycle. There's no such thing as a cycle of magnetic polar reversals. There is such a thing as a supercontinent cycle, but it's not rhythmic. It's not this pulsating 500 million year thing. Okay, but anyway, that's it. If you have any comments or questions, leave them below. I hope you learned something, and have a good day.